Good evening. In this video, we would be continuing to revise on some of the basic things which I think are quite common in the school days that we have learned. But I just thought to give a brief idea about this circle and the different properties and the circumference and diameter formula which basically comprises of circle. So it is just a very basic concept on the revision of the circle and its properties. Well, now, in order to start with the circle, what we first need to look over is that what is a circle? Now, as per the definition, we know that circle is basically a collection of points. So if we get a collection of points which is organized in a certain geometrical pattern, so what we get is a circle. So, for example, these are the points, so we join together and we get a nice circle over here. Now, the thing is that when we draw a circle, now this is just a basic demonstration, so let me use a deeper color so that it becomes clear. So if we draw a circle, it would be something like this, right? And what we can tell is that all the points from the distance from the center are equidistant to each other. So if I mark this as a center, so all these points, if this is say 2 centimeters or whatever, it would be same from here and it would be same from here. So all the points are equal to or equidistant, and that is what is basically the feature of a circle. Now a line segment, this is the radius. So from the center till the circle, what we get is what we call radius. So we can mention it as radius, right? Now, what is the diameter? The largest chord which passes through the center is called the diameter. So if this, we will just see what are the chords. So this is the largest one. So this is basically diameter. We can just denote it by D. So this is the radius, this is the diameter. Let me draw another graph, another circle, so that the further things becomes clearer to you. So let me try if I can draw a decent with free hand. Right. So what we get is that, say for example, we have known what is radius right from the center. Diameter is the largest chord. Now diameter, okay, so for the chord, see this one, what the definition of a chord is that any part of the circle. So this okay, fine, I will come to the chord part. So any line segment which joins two points of a circle, any line segments joining 2 points of the circle is called a chord, right? So these are the 2 points which are joining the circle is called a chord. So any line segments which is joining the 2 points of the circle is called a chord, right? The biggest chord is which runs through the center. So we got chord here. You see, if I got a chord around here and then a here. So what we can see is that at the bottom the chords are smaller, then it becomes larger. And this is the largest chord which runs through the center. It is called the diameter. This is the radius right from the center. So we can call diameter, if I can write over here, I can use writing that diameter equals to 2 radii, not the radius. So it would be the singular, would be radii, right? So diameter is twice the radius because radius is just the half, right? Now, what is an arc? Any part of the circle is called an arc. So this can be an arc, this can be an arc, any part. So this is basically the arc, right? Any part of the circle is called an arc. Now, for example, so we have learned what is a radius, we have learned what is a chord, we have learned what is a diameter. Now an arc which goes halfway, this is the diameter. The circle, now this part, if I call the circle, an arc which goes halfway, this particular part, this one is called the semicircle, right? So I can write this as semicircle. This is the semicircle. So what are the things that we have learned? Let us give us a basic overview. So we know what is radius, right? We have also learned what is a diameter. So we learned what is a diameter, equal to 2 times radii. We have learned what is a chord. Any two lines joining any part of the circle which joins 2 points is called chord. Also what we have learned is arc. Any part of the circle can be called an arc. So what is a semicircle? The arc which goes halfway round, right? The circle is called a semicircle. The length of the chords broadens, are smaller here, broadens and then becomes smaller and smaller, smaller and smaller further. Now, okay, now to this given another demonstration, let me draw another circle. Okay, so let me see a shorter one. Yeah. Now, when we draw an arc which is cutting the 2 points of the circle, say for example, this one and this one, okay. So, and another, say for example, this part which is cutting. So this one, which is the smaller part, is called the major segment. So we can write this as major segment. Okay, and this part, if I ignore this arc, this entire part, this is called the minor segment. Right, this is called the, oh, I'm so sorry. This would be the major segment. This would be the major segment. And this would be the minor segment. This would be the minor segment. So it is simple, major, minor. The maximum portion which is being covered is called the major segment, and this one is called the minor segment. Now there is an interesting observation which I would like to also show you. If I draw another circle, say for example this one, okay, and let me draw 2 points which would be the which will run in between. So I draw another this point, right? I may mention the center as O, as the origin, and this is A and this is B. Now if you see this, if AB, if I mention this AB as the diameter, so I mention AB equals to the diameter, I define it as D, right? So this OA, this portion, this OA, this one, OA is also equal to R. R means I'm into the radius, right? OA equals to R. OB also equals to R. OB also equals to R. So AB, this is a straight line, obviously will be equal to OA and AB. So I can write, say for example, if I write the line segment, say for example AB equals to the ray OA plus ray OB, right? OA plus OB, right? So this is equals to OB, OA and OB, and this is 2R. So this is R plus R, so R plus R equals to 2R, right? So that is how we get it. So that is how we get it. Okay, fine. So now we come to something which we call tangent, right? So let me draw another circle, and so this is one which is done. Okay, so let me draw a small circle like this, right? And say for example, if I get a point over here and I get a line like this, straight line, right? So a point, when a point meet a circle at only one point, this is the only one point, remember, it is called a tangent. It is called a tangent, right? And this point is called tangency. So I can write this as tangency, right? This is tangency and this is called tangent. Now another important thing is that the radius to point where the circle and the tangent meets will always be perpendicular to the tangent. That means, say for example, this is a tangent, and from here I draw another straight line which is a tangent. So this point, if I mention it as O, say for example, and I'm dropping this one, it's perpendicular. This is a little bit odd, yeah. So this it would be. So this one, this point and this point will always be perpendicular to each other. So if I mention it as O, A and B, this will be perpendicular to each other. Now let us come to an interesting observation. So we have understood what is a tangent. The radius to a point where the circle and the tangent meets will always be perpendicular to each other. When a point meet a circle at just at one point, it is called tangent. This is called tangentia tangency. Now say for example we are drawing another circle, okay, and for example we get an external point which is P. So this is O and I get an external point, say for example here, and it is P, right? So now how many tangents can be drawn? So I can see that from here, if I can draw one here and I can draw one here. This is crisscross. So let me draw another one for you. So let me take a fresh page and I will just draw for you. So this is, if this is a circle, right, and I get a point in here, an external point, right? So say for example this is a point P, and I can draw from here if I get, so it would just nicely cross this part and it would also nicely cross this part. So it is just cutting at this point, right? So I mentioned this as the center as O. This is the external point which is P, and I know that these are perpendicular which we have already drawn over here. So I can call it as A and this is B, right? This point is P. So if I drop another perpendicular from here, so what I get over here is angle PAO, this one, this angle, right? This part. So I can write angle PAO will be and angle PBA, that is this angle PBA, yeah, these are right angles, right? Angle PAO and PBA in length are right angles, right? Are right angles. Okay. Now PA, this one, PA and PB are all equal. So we can write PA equals to PB. And OA, this one, and OB, and OA and PA, this one, OA and PA are perpendicular to each other. So I can write OA is perpendicular to PA, right? And OB automatically becomes perpendicular to PB. So OB becomes perpendicular to PB. So from an external point, we can drop in two tangents. This one and this one are perpendicular to each other. So that is the reason that these angles are 90 degrees. And this is how OA becomes perpendicular to PA and OB becomes perpendicular to PB. Right? Now we come to the next part. Let me first draw it and possibly then you will have a clearer picture. So for example, if I get a polygon, we can call it, right now we are drawing something like a quadrilateral. So let me draw, say for example, if this is a polygon, okay, right, and we are joining the vertices. So it looks something like this, okay. So this is what we call a polygon inscribed in the circle. So we can write this as, so let me name this as A, B, and then C and D, right? So what we call this as a polygon, this is a polygon, although it is a quadrilateral, never mind, is inscribed in the circle. So this is polygon inscribed in the circle, and this circle is circumscribed about the polygon. So these are two words, one is inscribed and another one is circumscribed. So polygon is inscribed in the circle, and I can write it as circle. Circle is circumscribed about the polygon. About the polygon. So these are the two new terms we have learned. The one is inscribed and circumscribed. So polygon is inscribed, that is it is within the circle, and circle is circumscribed, that is outside the polygon. Now for example, if we take another example, say for example, let me draw it below so that you can understand. So now for example, if I take a circle, right, if I take a circle, and then what I do is that I draw a polygon. So in this case the polygon is circumscribed about the circle. So how do we do that? We can use like this, right? This comes here. Okay, something like this. This would be extending further. This would be extending further. So let me draw it once more for you. This would be. Okay, let me draw it fresh. So it would be like this one. Okay, so this is polygon circumscribed about the circle. So what we do over here is that this is the wrong one. This one is which has got the outside. Now what I will do is that we will draw something like this. So this one is outside and now we are drawing it inside. So we draw it something like this, and then we draw like this, something like this, although it is not a perfect figure. So we can further name it as ABCD. So for example, we are naming it as A, B and C and D. So in this case what is happening is that we can write this polygon is circumscribed about the circle, is circumscribed about the circle. This is polygon, this is circumscribed within the circle. So inscribed means inside, circumscribed means outside. So this is one where this is inside, this is outside. It is just the opposite. This is outside and this is inside. Now for example, if we take another figure, it would look something like this. Say I take another figure. So we take a circle like this, right, and we draw a polygon like this. Okay, and what we do now is that we name them as ABCD. So we put the labels as ABCD, right? This is a cyclic quadrilateral, so we called it as cyclic quadrilateral, right? Now the opposite angles always add up to 180 degrees. So any angle which is further extending, like if I extend this part further, like, so what I can say that angle A, this angle A plus angle C equals to 180 degrees, right? Opposite. Now angle B plus angle D will also be equal to 180 degrees because it will eventually sum up to 360 degrees. This will eventually sum up to 360 degrees, right? Exterior angle is equal to interior opposite angle. That means angle BC, so angle BCE would be equal to angle DAB, this one, DAB. So if I further extend it to, okay, let me draw it once more for you. Okay, here comes. So we get a circle, and then we inside get a polygon. This is a polygon, and we name it as A and B and C and D. Now we extend it further to E. This one, this is an extension. So we can tell angle BCE, this one. So angle BCE will be equal to angle DAB. This one, this one. This one and this one are equal because they are exterior equals to interior opposite angles. Now what we can write just from the previous one, we have already known that if we go back to the portion that we really started to. So let us go back to where we started. Yeah. So now you see from here, this part which is already given. From here, what we can write is that this part. So from this part, what we can do, you see that circumference and the diameter concept is clear over here. This one, circumference, diameter. So now from here, what we can do is that we can definitely write that circumference, if I put it as this, circumference by diameter, okay, is always equivalent. I cannot write equal, it will always equivalent to pi, that is 3.14 something, right? So from here, what we can quickly write, if I put it as C by D equals to pi or equivalent to pi, right? So I can say C is equivalent to pi times D. Now D, what we know, is equal to 2R. So eventually what implies is that C is equivalent to pi multiplied by 2R, and from here we get C equivalent or equal to, in general common, equals to 2 pi R. So this is the way in which we can deduce the formula. So this is a nice approach to knowing the basic parts of a circle. So let us move on to the next part. So for the next part, we will draw a simple circle again, and so here comes the circle, and we take a center, we draw a straight line, right? Okay, so we mention it as OA, the center we mention it as O. We take the 2 points here as A and B, right? And we take this as R, and we take this point as P, X and Y, right? Now our main problem is that how can we find the distance between the points? So in that case, from this particular figure, what we can quickly write over here is that the distance between OP, let us put as distance as DOP, right? So we can say the distance is nothing but the radius, this one, the R, right? So this is nothing but the radius. So DOP equals to R, this the distance. So how do we find the distance? Now we can use the distance formula over here, which we already know. So what we can write over here is that root over of, obviously that comes from the distance formula, x minus a whole squared plus y minus b whole squared equals to r. X minus a, this point to this point, and y minus b is y to this point, equals to r. So now if we square both of the sides, which is a general rule what we do, so what we get is r squared equals to x minus a whole squared plus y minus b whole squared, right? Now this is a generic, this is a very generic formula, right? Now how can we calculate where the origin is 0? Now say for example I take this and I take the origin not as a and b, we take it as 0, 0. That is x equals to 0, y equals to 0. So here what we will do is that we put it as a equals to 0 and we put it as b equals to 0. So from this what eventually we get is that if we use this same formula, this one, right? So we get x minus 0 squared plus y minus 0 squared equals to r squared, and from there we get therefore x squared plus y squared equals to r squared, right? So this is one particular formula which is a generic one. Both of them are generic one. This carries origin as 0 and this carries origin as maybe a and b, etc. So we have two formulas, this one as well as this one. Both of them are correct. Now what we do is that we want to calculate the area of a circle. Okay. So previous to Pythagoras, or when we really find out the circle and the formulas which was not known during that time, it was obviously an intuitive approach that the mathematicians took. So what they did is that they drew a circle, right? And because it has got no length, breadth, height, which is common to rectangular or quadrilateral figures, what they did is that they tried to divide this circle to infinitely small parts. So first we draw a straight line and then we try to divide this as small as we can. So we continue dividing these into infinitesimal parts. We go on dividing and dividing and dividing until this becomes a rectangle. So if I take a part of slice out of this, it looks something like this, you know, it looks something like this. So we get one here over, okay, and then we get one over here, then we get over here, and we get over here, and we get over here, and this actually continues, right? It continues until it becomes a kind of a rectangle. I mean to say, like, it is similar that you are taking parts from the pizza that you are eating and you are arranging them and it becomes kind of a rectangle. Now from here what automatically becomes is that the area of a circle becomes equal to the area of a rectangle, right? So this is some kind of an analogy which the mathematicians in those old age they found it. Now if we can found that the area of a circle equal to area of a rectangle, we know what is the area of a rectangle. So if I can abbreviate it as R, that is the area of a rectangle, we know that the area of a rectangle is base multiplied by height. Now, right? Now height of the rectangle, if I take this height, what is this height? The height of the rectangle is the radius of the circle, right? From here till here. This one, this has been divided, right? This is the height. So this part has been divided. So I can put it that as that the height equals to radius. So I can write here height equals to radius, right? Height equals to radius. Now we know that the base is equals to half of the circumference. So I put it as half c. Why base equals to half of the circumference? Well, you can intuitively understand that the base, if the circle is this one, you know, this is the circumference. So the base would be like you open this part and becomes half. It becomes half. So it is something like this, and then you open it becomes this, and then you rotate it, it becomes like this. So base becomes half of the circumference, right? So if base equals to half of the circumference, what is circumference? So I can put it as circumference equals to 2 pi r. Why circumference equals to 2 pi r? In this part we have seen in the, let me go back to that part. Yeah, this one. We have seen that circumference equals to 2 pi r. So from here, if I come back to my original equation, if circumference equals to 2 pi r, so what I can do is that I can substitute the values of base, the value of base equals to half, right? So what I am doing is that I am trying to find the base equals to half multiplied by 2 pi r, half of the circumference. So half multiplied by c is what? 2 pi r. So I am cancelling out the 2 and 2. What I am getting is pi r, right? Now pi r times r, which is the radius, because height equals to radius, we get pi r squared. Simple. So this is a very useful way in which I can find out the area of the circle. You can further write that because the area, you can further write area of rectangle as because it is equal to area of circle, right? Okay, and area of rectangle is equal to pi r squared. So the area of circle will also become to pi r squared, therefore pi r squared, right? So that concludes our video. So let us quickly find out what we have learnt. Just let us go back and get to the basic revision part. So we have understood that why the area of a circle is pi r squared. We have learned that area of a circle. So this is how we do. We have divided this part. We have just substituted the values which we have learned, and we have got that base equals to half 2 pi r equals to pi r multiplied by r, it is squared. This part is done. We have also learned why circumference equals to 2 pi r. So this is a kind of intuitive approach. You can do it in your home. You can take a glass, you can take a pot or anything, and you can measure it with a thread. It will always, the circumference, length of the circumference measure divided by the diameter, it will be equal to pi. Always. You can do it at your home. So substituting the values, we can find out c equals to 2 pi r. This is a generic formula. Both of them are correct. This is with the origin as 0. This is the origin as x and y. We have also learned what is a tangent, how we can find the values of tangent, right? And we have also gone through what is a radius, diameter, chord, and an arc. So this actually brings to the very end of the basic basic understanding of circle. What you can also do is that if your time permits at all, you can just quickly get over to the revision part, that what are the formulas which you can just quickly write. Let me see if my time permits. This videos get a little bit longer. So I can always write formula number 1, A equals to pi r squared, that is the area. Circumference equals to diameter times pi, so automatically, and diameter equals to 2r. If I draw a chord, AB and CD will always be equal to each other. So say for example, yeah, AB will be equal to CD. So this is the circle and I'm drawing two chords, right? So this part and this part, and this is the second, third, and the total angle of the circle will always be equals to 360 degrees. So just a quick revision: area, circumference, diameter, chords, and the degrees of the circle. I hope you like the video. It is a little bit lengthy one, very basic. So those who really want to avoid this video, they can, because it doesn't contain any advanced part. And thank you for watching it. So we'll be coming up more with similar types of videos, brushing on the concepts. Thank you very much. Have a good day.